Okay, so I'm on the BBC Bitesize website, which is where they give you an idea of, it's an example of how you might generate a check digit. So if you give it the barcode 2142345, then it will take the odd numbered or the odd positioned digit, so the first, third, fifth, and seventh, so 2, 4, 3, and 5, and it will times those by 3 and add them all together. So it tells you here that if you do that 3 times 2 plus 3 times 4 plus 3 times 3 plus 3 times 5, you get 42. It then takes all the numbers in even positions, so 1, 2, and 4, and it just adds them onto the end. So 42 plus all of that gets 49. It then does 49 divided by 10, or in your program you might use mod 10, because mod 10 does the division and tells you what the remainder would be as an integer. So that gets you 49 divided by 10 is 4, remainder 9. So the remainder, or the result of the mod operation, is 9. And then the final step is taking that away from 10. So 10 minus 9 is 1. So the final barcode would be this number, and then a space, and then a 1 at the end. And what's the point of it? Well, if you then use a barcode reader, which could be slightly unreliable due to issues I told you about yesterday, issues that we talked about, there could be tons of reasons why data gets corrupted, from electromagnetic interference or other types of interference in like radio waves or stuff like that, if it's to do with mobile communications. There could be the barcode itself, which hasn't been printed very well. It could be that there's a short circuit happening or something else happening in the circuitry. Could be that if you're sending data over a network, all sorts of things could happen over the kilometers that data is traveling down all sorts of wires, including loose connections and things like that. It's very possible that data can get corrupted. If at the other end you receive the number 2142345 space 1, what you can do is you can ignore the space 1 and you can run the exact same function on the data, 2142345, and it will also give you 1. So if it gives you the same check digit as you received after the space, you can presume that you've received the data correctly. And if you just imagine that one of these numbers had become corrupted, if it was 2142346, then chances are the check digit would be different, and the number after the space should be 1, you know that because that's what you received, space 1. But if you then do the maths on this, you get a different number and you go, hang on a minute, something's gone wrong here. I need to re-request the transmission. I need to get that data sent again. And if you're thinking ahead, you might realize it's not a flawless system. If you corrupt a few of these numbers, it's very possible they will also generate a sum, like they could generate 69 or 89, which is also remainder 9 when divided by 10. So the check digit will come out the same. So it's not a foolproof system, but it's just yet another layer of processes that you can add to allow, to sort of try and ensure that your program is robust. Yeah, so it can start with checking user input. If you need a number and they give a string, you can say no. But then if they give a correct number and then you're sending that number down a wire or across a wireless, using wireless or whatever, then when it's received the other end, you can then use check digits to see if that number is the same as when it started, when it was sent. So there's all sorts of different ways that you can check your programs are robust. One can be controlling what the user inputs, one can be ensuring that data is sent or transmitted across a wire, and not corrupted along the way. Okay, so good luck programming it in Python. Here's my program. You can just have a quick glance. I've pasted into a comment at the top the stuff from the BBC Bitesize website so I could refer to it in my code. I've defined my function, which takes a string of numbers, and you can just see the very start of what I've done. I've got total equals 0, so something which is going to be added to throughout the course of the function, and then I start to loop over all the odd numbered digits. That line there, might help you, because it's a 3-argument for loop. It's a for loop which starts at 0, goes up to the length of the data that was passed in, and jumps by 2 each time. So that's a way of getting only the odd number things, going 1, skipping 2, going to 3, skipping 4, going to 5, so 1, 3, 5. That's a technique that you'll probably want to use when you write your own one of these.